This video is devoted to really a single topic because it's so important, and that is learning how to do the repeated computation commands. Excel has this ability to do repetitive computations very easily. Let me show you what I mean. Here's just one example. There's several that I'm going to try to illustrate. Suppose I want to create 10 data points and I want to number them 1 through 10. Okay, I can start off with that. But now notice what I can do. I can tell Excel, in the following row, take whatever in the row above it and add 1. And if I simply pull this down, and let me make more data points than 10, otherwise it's not really worth it if you don't have a lot of data points, right? Okay. Notice I made all of those automatically. Let me create, and now I can go ahead and let me just create one more row. So I'm going to create a row here, and I'm just going to put some data in. It doesn't really matter what it is. I'll just make up something here. We'll just put in something from a normal distribution. Okay. And I'll put this here. Okay. Now notice that I can do different sorts of things with this, okay? For example, I can use this command to repeat calculations on a column. So suppose I want to add up all these numbers from 1 to 30. I have to be careful. I can't use Control-Shift-Down because I have a command there. Okay. So this is the sum. And notice if I simply pull this over, drag this over, it automatically sums everything in the second column. Okay, so you can repeat calculations across the column by just dragging across the row. By dragging this row, it repeats the same calculation for this column. Okay, let's do a few other calculations real quick. One of the things we're going to want to do for a normal distribution every once in a while is we're going to want to compute a z-score. I'm going to compute the mean of the y's. So I'll do average and compute the standard deviation. It's a sample. I'm going to assume it's a sample from a population. Okay, and now I'm going to compute the z-score for y. Okay. And so I'm going to repeat this calculation, but now I have to be a little careful. Remember what the z-score is. Let's back up and review what the z-score is here very, very briefly. It's equal to the data value, and in this case happens to be y, called y, minus the mean divided by standard deviation. Okay. And so I'm going to start off. I'm going to say, okay, subtract this from the mean and divide by the standard deviation. And if I pull this down, okay, I'll want to compute it for this row right here. The problem is Excel can't do this, right? Because when I pull this down, notice what happens. If I click here, it says, okay, subtract B3 from F3 and divide by G3. In other words, it not only pulled this number down, it pulled these two numbers down too, which I don't want. So what I have to do is I have to anchor. So sometimes with the drag commands, I have to anchor values that I don't want to move, because I want to subtract the same mean from every single data value and divide by the same standard deviation. So by putting these dollar signs on both sides of the letters for the cells that I don't want to move, I'm not going to have this problem. Okay, now when I drag it, watch what happens. Okay, it used B3 like I wanted it to, but it held the mean and the standard deviation fixed there. And of course now I can just drag this down and repeat everything for the column. Okay, so these are very, very useful sorts of calculations to be able to do. And again, I could, if I wanted to, although there's really no reason why I'd want to sum these, but just to show you real quick. Okay. If I want to repeat a calculation like sum, on a row, I just drag this down. And now this performs the sum of every single row just by dragging down the sum command. It understands it wants you to sum what's in the row below. So these drag down commands are very useful. They're very helpful, and we're going to use them a lot. They really make computations much more quicker than if we had to do each of these by hand. That would be a real pain.